My dear students, uh, my dear students, now we are going to discuss the kinematics of machinery, third unit part. Uh, Earlier, we discussed the first two units, the basic topics in kinematics of machinery, but now onwards, we will discuss the main topics. Our subject also, its name is the kinematics of machinery. Now we will discuss the entire thing. First unit and second unit we discuss like basic things, simple what is the element or link, what is the link, what is the mechanism, these type of things. But now we will discuss the kinematics of machinery. Before we are discussing the machinery, first of all in this unit we will discuss the kinematics. I think you know very well. In the introduction class itself, we discussed regarding the kinematics. What is meant by kinematics? We know very well that is kinematic deals with the relative motion of different parts of mechanism without taking into consideration the force producing the motion. But dynamics means here we have to consider the force also. But here we will consider motion of an element without considering the force. That is a very important thing. Now, while you are doing the any analysis part of a mechanical component, moving component, that component you have to know the its velocity or acceleration, etc. If you know such type of things, then you can analyze in dynamic manner also. But in the statically, here in engineering mechanics subject, you did the some analysis how the force is resolved or what type of effect is taking. In strength of material subject, already we studied that is due to that particular force, what type of deformation takes, like that. Now here in this particular kinematics case, whenever the force is acting, here force is dynamic case, whenever the force is acting, due to that force, here how that one is moving, with what velocity and what acceleration, what is the next effect also. But in the kinematic case, we will ignore the force, but we will choose the motion. Why? Because in this particular subject, first of all, we will discuss only motion of an element. But in the next semester, we will study the dynamics. At that time, due to the force, how it is taking the effect, what is that particular effect, all these things we will discuss. Okay. Now here, I think you know very well that is a linear motion and rectilinear motion, etc. Now whatever may be the motion component or whatever may be the motion, now we have to know the its velocity and acceleration condition. That's why now first of all we will discuss the different types of motions. Why I am saying here different types or classification of motion means here motion generally when I am telling here whenever a component is moving from one position to the another position, definitely we have to define with respect to the some reference point, with respect to the some reference point. That's why here I think in engineering drawing subject or CAD type of subject, I think you know the some of the coordinate systems, relative coordinate system or absolute coordinate system. In the same manner here also, with respect to some reference axis, we will define the motion of an element. That's why here that classification is comes to the two categories, that is the absolute motion and relative motion. Absolute motion and relative motion. Absolute motion means preferably absolute motion always we will define with respect to the earth most of the cases. That is actually with respect to the moving element we will define with respect to the fixed element. That fixed element we will consider as a earth. But some of the cases, adjacent moving element or adjacent fixed element, we will treat it as a axis or a reference line. With respect to that reference line, if you define that system, we call as the relative motion. Relative motion. That's why here I given a one small example. That is, suppose a man moves inside the train. Suppose any one of the person is moving inside the train. Then how we will define the motion of that particular man? if you want to define in relative manner, if you want to define in a relative manner or absolute manner, how we will define? Suppose here here motion of the man relative to train, relative to train. Here we will define with respect to the train only. With respect to the train only, at that time it is the motion of the man assuming the train to be stationary. Train here, now we will assuming that case train is a stationary condition. That is here actually if you observe, train is also moving, man inside the train he is also moving. Now we are defining the velocity of the man with respect to the train. That's why with respect to the train I am defining. That's why train I will consider as a fixed element. You understand my point? So that's why with respect to the fixed element, that is the train, I will define relative motion of the man with respect to the train. Simply we call that one. And but if you want to define with respect to that is the absolute manner, or simply we can call it that one as a motion of the man, or absolute motion of the man, or motion of the man relative to the earth. In the beginning I said, that is whenever we are defining with respect to the earth, we can consider that one as the absolute. So here for absolute case, simply we can write absolute motion of the man or motion of the man relative to the earth. This particular thing we consider as a absolute motion. That's why here what I wrote here, motion of the man relative to the train plus motion of the train relative to the earth. Both we have to consider, not only single one. That's why here in absolute case, here from the beginning onwards we have to consider the motion. Okay, next we will consider, this is the velocity. I think 9th standard onwards we know the velocity, acceleration, all these things. All these things are comes under the category of the vector mode. So here first of all, what is the notation of vector? How we will define that particular vector? That particular thing we have to study. Here that's why here characteristics of a vector. Why? Because here velocity is a vector quantity. Why we are saying this one is a vector quantity? Velocity is having a certain magnitude and as well as a particular direction is there. Without direction, your element is not moving. It is having a particular direction. Or in your mechanism, especially in our mechanism, definitely your machine element will move in a one particular direction. That's why we have to say this velocity component is a vector quantity. Why? Because it is having the magnitude and as well as the direction. Suppose here I take in some examples how we will indicate. Suppose AB, this is the A portion, is the tail portion, and B is the head portion. Why I call this one as the head portion means at the head portion simply I represent with the arrowhead. So here AB is there. So simply this particular one vector we call as the AB vector. But that's why here in vector manner, whenever you are representing that quantity, we will take a one suitable scale. That suitable scale in particular direction, whatever the direction is there, in that particular direction, we will represent this AB line. In the same manner, suppose if I wrote this particular BA, here BA is in a reverse direction. That is here, if you observe, if you compare these two, AB is equal to minus BA. Why I taken minus BA? Here it is changing its direction. That's why I taken the minus sign. AB is equal to minus BA. Minus means it changing its direction. Sense of direction it represents. Suppose certain times without indication of arrow head also we can represent the vector. How we will represent? Just you study this particular one. VBA. What does it mean? VBA. Velocity of the B. Velocity of the B relative to A. It means velocity of the B relative to A. But here, suppose here we can represent it in two different manners. Most of the cases we can write like this, B suffix BA. Otherwise here in this particular case, simply we can write AB. AB means velocity of the B relative to A, or VBA also. Here VBA means velocity of the B relative to A. here, but if you observe in this diagram, I did not mention here arrowhead. That is here for simplification purpose without any rotation. Once again, I draw that particular diagram in this particular manner. BA. Okay, here I note down the sum of the points also. Whatever the things I explained here, same points I represented here also. Just you go through this particular material, you can easily understand. Okay, my dear students, try to follow. Next, here, suppose vector quantity. This one is the velocity is a vector quantity. If you want to add this vector quantity, how we will add this particular thing? And you know very well all these things, even though for easy understanding purpose only, I taken this type of examples. Suppose here I represent some of the velocity vector notations. Suppose OA, AB, BC, CD. That is OA. It is the here OA. It represents the velocity of the A relative to O. AB represents the velocity of the B relative to A, and so on. Okay. Actually, here all this particular one, if you how we will find the resultant of, suppose I want velocity of the T with respect to the O. If you want to find velocity of the T with respect to O, how we will find? First of all, we have to draw the velocity diagram in one particular sequence. Suppose you consider this is one of the link element, or you consider this is the another element, this is the another link component, and so on. Finally, with how much velocity that mechanism is moving, if you want to find that thing, here we can construct the velocity diagram. First of all, while you are constructing, this is the velocity diagram, complete velocity diagram. And now, while you are constructing velocity diagram, we have to take a graph and we have to choose a suitable scale. That is, suppose 10 meter per second is equal to 10 meter per second is equal to 1 mm or 10 mm. Like that, we have to select a one suitable scale. Then we will start the diagram. Here, OA. What does it mean? OA means velocity of the A. Head portion is the A is there. That's why velocity of the A with respect to O or relative to O. Relative to O. Here, you take the suitable scale. Whatever the direction is there, you draw the diagram in the same direction. Draw the diagram in the same direction. So I represented in this direction. Next, here this is the tail portion of the link OA, and this is the head portion. Next, adjacent link is the AB is there. That's why A tail portion. This is the A tail portion. Now you take this point, head portion of the previous line, arrowhead. Now here. Now from this particular point onwards, you start and construct this particular line with suitable scale in the same direction. Now indicate one arrowhead and indicate that particular point as the B, and continue the same procedure. Next BC, we observe in the same direction. I draw this diagram. Next CD is there. This is the end point of the D. Now you start the dashed line, or with a different color, you construct a one line from O to D and indicate this particular arrowhead. Now you measure this particular thing, and this is the velocity of the D relative to O. Okay, do you understand my concept here? That's why here simply I wrote this one is the VDO, velocity of the D relative to O is equal to, here whatever the elements you consider, all the element velocity you have to take. That is velocity of the A relative to O, velocity of the B relative to A, plus velocity of the C relative to B, plus velocity of the D relative to C. So here 4 number of elements are there, 4 number of elements I added in vector manner. Next, that is so suppose in the previous case I mentioned, that is without indication of V symbol, simply we can write simply OD. OD means same meaning, but we have to represent this thing in reverse manner. You have to remember that thing, very very important. Without writing of V, if you want to indicate, simply you write OD. OD means velocity of the D relative to O. Okay. Now, here, once again, without confusion, better to write down all these suffixes in reverse order. All these above equation, all the suffixes you write in reverse order. So, you observe BC, CD plus BC plus AB plus OA. Okay, this thing is nothing but a, that is you can write the equation either in this particular form or this particular form. Both are equal. That is specifically here we are mentioning the velocity. Here in vector manner we are specifying that element. Okay, both are same. Okay, in this particular way we will add one element with the another element and we will find the relative velocity of the any one of the link with respect to the adjacent or next fixed element. Okay, like that we will add one element with the another element. Okay, next here, okay, that is the basic thing. Now suppose if you take any one of the mission component, if it is moving with a certain speed or certain velocity, what is the motion of the link component? Just now we will discuss. That is here, if you observe this particular diagram, motion of the link, I take in one of the rigid link, that is the OA. That is the rigid link OA. That one is rotate about a fixed point O with uniform angular velocity omega. Okay. Now that is the length of the link OA portion is the R. Don't confuse. This R, it represents the length of the link OA. Okay. Omega is the angular velocity. This one is rotating in anti-clockwise direction where it turns. Now suppose whenever if it turns in anti-clockwise direction, OA is the original position. If it occupies a new position as the OA dash, OA dash. That is A is occupies the new position A dash. That is here whenever it is moving or occupying A dash, it is rotating delta theta degrees. I taken a small motion, small movement only. Okay. Whenever it turns, it is the delta theta. I think you know very well. Velocity of the A. Suppose if you want to find the velocity of the A relative to O means what is the velocity formula? You know very well. Distance divided by time. Okay. That is I take in a very small time period and a small interval of time period. That's why it moving small distance delta theta angle only. So that's why here distance is the A to A dash. Arc length A dash divided by delta t. VAO, I represent our notation. Velocity of A point with respect to the R relative to O is equal to A dash. What is the arc length of A dash? You know very well. Arc length is nothing but a radius into angle. That's why radius is nothing but here length of the element into how many degrees it is rotated, delta theta degrees, or delta theta divided by delta t. Suppose that interval is that limits delta t tends to 0, we can write that equation as VAO is equal to, that is the velocity of the A relative to O is equal to R d theta by dt. What is the d theta by dt? You know very well. That is the R omega. We know that formula. V is equal to R omega. V is equal to R omega. How this particular one is moving? Always our displacement is perpendicular to the your link motion. That is that motion is perpendicular to the link. Okay. Now suppose, but suppose sir, this is you calculated. You may have certain doubt. That is sir, you calculated velocity at point A with respect to the R relative to O, but I want to find velocity at some other location on the same link, at B or some other location C or D or somewhere. If you want to find some other location, at that time how we will calculate? That is in the same manner we can easily calculate that is the velocity of the B. Suppose if you observe velocity of the B on link OA is equal to omega into OB. Why it is same sir? Omega into OB means OB is the your selected portion length value. So angular velocity into V is equal to R omega. You the omega into OB. That is here. If you have any doubt, just you see this particular one, proportionality relation. OB by OA. That is OB is the velocity of the B relative to O. Here velocity of the A relative to O. That is omega OB by omega OA. Here omega angular velocity is a common constant. The remaining thing is the OB by OA. That's why here definitely here that is your angular your relative velocity is proportional to the distance. Proportional to the distance. You have to remember this particular thing. Okay. Next, now we will move to the, suppose I will take one small example in this particular class. Now, four-link mechanism. Now I will explain one simple diagram. Four-link mechanism. Suppose how we will construct the velocity diagram for a simple four-link mechanism. I think in first unit we discussed the four-part mechanisms, etc. So that's why suppose for easy understanding purpose I take in this particular example four-link mechanism. Just observe here, AD is the fixed link, one of the link portion. AD is the fixed link. I am saying, unfortunately I did not write here dash lines, but AD is the fixed link. Next link AB. Next link here for my explanation purpose, this entire thing I consider as a one link. What is that one? BCF I consider as a one link. Next CD is the fourth link. Okay, you understand? In this particular case, AD is the fixed link. Okay, BC is the coupler. BC is the coupler, and AB is the rotating element. Rotating element. That is that rotating element. I taken this one as the clockwise direction. This is a rotating element. That's why we can call this one as the crank. Okay, okay, and here it is the oscillating is there, so we can call this one as the rocker. Now fixed link. This is the coupler. Crank is there. By using this one, we will get a certain motion. Okay. Now, suppose if you want to find the, that is this link is having a output motion. If you want to find the output motion of this particular link, that is suppose for my convenience I will take this particular point C. That's why velocity of C relative to A. Why? Because A is the fixed point. That's why I will write velocity of the C relative to A. How we will write? In the beginning I explained. That is first of all I will take. It is not a direct link. Two links are there. That's why I will take velocity of C relative to B plus velocity of the B relative to A. Okay. The same thing I wrote here in the equation form. If you study my material, you can easily understand. Okay. Once again I will explain. Just you see, go through the diagram. That is velocity of the C relative to A. I want to find velocity of the C with respect to the fixed point. At that time, I am expressing that thing, velocity of the C relative to B plus velocity of the B relative to A. So, if you write in the equation form, VCA is equal to VCB plus VBA. Okay. If you write that particular thing in vector manner, AC is equal to AB plus BC. AB plus BC. That is here the same thing. Here, if you observe here, AD is the fixed link. AD is the fixed link. The same thing you can express in the another form also. Instead of A, you can write D term also. Because AD is the located on the same fixed link. That's why here instead of A, we can express VCD is equal to same one VBA plus VCB. VBA plus VCB. That is vector form also we can write DC is equal to AB plus BC. Okay. Now that is here. First of all, we wrote that equations. Now with respect to that particular diagram, how we will find the velocities? That is here. If you observe this particular diagram, after that you read the material. Just you go through this particular diagram. First of all, take AD. AD is the fixed link. That's why take A and D points at same location. take A and B points at the same location. Okay. Next, take the suitable scale. You know the angular velocity of this particular link AB. What is that one? Omega is there, omega radian per second. Now you calculate the linear velocity, relative velocity of the B with respect to A, that is VBA is equal to R omega. R is nothing but a AB into omega. By using the relation, you calculate the VBA. Now, VBA link line is like this. In the last explanation, I said the direction of the motion is perpendicular to the element. So, suppose if this link is moving in clockwise direction, that clockwise direction is perpendicular to the this AB link in this particular direction. That's why I taken a suitable scale. I drawn the VBA line in this particular direction. Okay. Okay. Next BC link is there. What is the BC? C means the velocity of the C relative to B. We don't know its magnitude, but we know the one direction. What is the direction? The direction of that particular one is perpendicular to the link or element. So that's why this is C at point C. That is at point B. You draw a one line perpendicular to the BC link. So at point B, I constructed a one line perpendicular to the BC link. BC link perpendicular to the BC link. So here I drawn one line perpendicular to the BC. Next CD is there. CD, VCD. So CD means velocity of the C, VCD. Velocity of the C relative to D. Here also we don't know its magnitude, but we know its direction. What is the direction? Its direction is perpendicular to this link element. So in this particular perpendicular direction, I drawn one simple line. Where these two lines, earlier BC line and CD line, where these two lines are meet each other, indicate that intersection point as the C. Okay. Now our velocity diagram is completed. Now here you measure this VCD length value. That is, earlier we wrote that equation. VCD is equal to VS. That is VCA is equal to here VCD. That means here both are same. So here you can calculate the velocity value. Okay, velocity of the C relative to D. Now I will stop my class here. Why? Because if I explain lengthy, it takes more time to uploading my video. That's why I will stop. If you have any doubts, please ask me in WhatsApp group. Okay, please contact me without any hesitation. Thank you, one and all.